Good afternoon to everyone. My name is Juan Zambrano. I'm a PhD student at Oregon State University. My research is about the effects of intermodular connection stiffness on the seismic response of modular mass timber buildings. I wanted to start talking about why we choose mass timber modular buildings. We know from the benefits, the environmental benefits and weight reduction that we can get from mass timber buildings. But with modular construction, we can have a time and cost reduction with prefabricated modules. In addition, we can reduce the amount of energy and the waste produced during the construction process of these type of buildings. At the end, finally, but not less important, we can also increase the forestry practices for sustainability using this type of construction. One of the key components for mass timber modular construction are their connections. We have the intramodular connections, intermodular connections, and connections to the foundations. In this case, the study focused on the intermodular connections, that are the ones that connect the modules next to each other. For this, we perform a parametric analysis in which we evaluate using OpenSea's 3D models for 9, 12, and 18-story buildings to analyze the influence of the stiffness of the intermodular connections and the behavior and their influence over the diaphragm behavior. For this, we evaluate the location of the modules using two types of locations, at the diaphragm and at the column, based on the description that are on the plot on the left at the bottom. And we modify the horizontal stiffness and the rotational stiffness in different ranges to analyze the response of the structural system. Based on the results, we can conclude that the diaphragm deflections increase exponentially when the horizontal translational stiffness of the connections decreases. As you can see in the plot, we have the response for both types of connections, the diaphragm connection and the column joint connection in both directions. Both of them reflects the response of the building, in which you can see that when the translational stiffness of the connection decreases, the diaphragm deflection starts to increase. In addition, for the building periods, we have the same behavior, that it's proportional for the building height as it's in any type of the building, but in particular, these type of buildings, they also tend to increase their period when the diaphragm behaves in the semi-rigid or flexible region, increasing the period of the response of that building. Thanks for your attention, and I will be in the poster session also for any questions.